Okay, finally into the questions. We're dealing with grade 10. This is functions. We have a linear function, we have a quadratic function. We'll deal with 2.1 and 2.2 in this video. Like the videos, subscribe to the channel. Drop a comment if there's anything that you maybe didn't understand or want me to re-explain or maybe make a new video on, and share the content as well. Okay, so let's go and look at question 2.1, 2.2. They're asking for intercepts, okay, specifically the x-intercepts, but I'm just going to discuss both quickly. So here's a Cartesian plane, okay. This over here is your y-axis, this over here is your x-axis. And if I put some random numbers here, so this is 1, this is 2, this is 3, and on so forth, and on that side obviously the negative values. On this point over there, that dot that I've made now, the x value is 1, the y value is 0. This dot that I'm making here, let's get that back. This dot that I'm making here, the x value is 2, the y value is 0. Over here, forget about the x value, the y value is 0. Y value 0. Y value 0. Y value 0. So everywhere, what I'm trying to show you is everywhere on this line, everywhere on your x-axis, your y value is 0. So when I want you to find the x-intercept, you are going to make y 0. Why? Because everywhere on that line, the y value is 0. And what is the x-intercept? It's a place where your graph cuts your x-axis. Okay. Similarly with the y-axis, so this line over here, if I'm over there, your x value is 0. X value 0. X value 0. So everywhere on your y-axis, x is 0. So when you want to find your y-intercept, you're going to make x 0. When you want to find your x-intercept, you're going to make y 0. The reason for that, because everywhere on your y-axis, x is 0. Everywhere on your x-axis, y is 0. Great, let's get into the questions. So over here, the first question, find the x-intercept of h. Okay, they gave us that equation. That's nice. So we're going to say h of x is equal to x minus 2. So this is a linear function. You know it's linear because the exponent on the x is a 1. So here there's a 1 as an exponent, right? And it looks like it is in the form y equals mx plus c. Okay, so you know that your m value is 1, so it's positive, so the graph is going up, which you can obviously see from the picture. And your c value is minus 2, so obviously this thing went down 2 units if they asked you for that, right? So you know those kind of things. We did a video on that, so go check that video out, but you know those kind of things already. Okay, let's maybe just also mention this over here, right? So if you're confused by that symbol, this is our function notation. If you're confused by that, just replace this whole thing with y. So I could say y is equal to x minus 2, and I would be saying the same thing as this. Okay, so if you're confused by your function notation, that whole symbol h of x, go replace it with y. Okay, function notation will become more important later on. For now, let's not make a big deal of it. We're just going to think of it as y. All right, so you need to find your x-intercept. So how do you find your x-intercept? As we've mentioned, to find x-intercept, y must become 0. So this whole thing over here is our y, so we're going to replace it with 0. So we'll say 0 is equal to x minus 2. Some manipulation here so that x can be the subject. So we're going to add 2 on both sides, so it will be 2 equals to x, or x equals 2. We like having our variable on our left hand side, so let's just say x equals 2. The coordinate for this is going to be 2 and 0. Okay, so let's go back to the picture. 2 and 0, that is going to be over there. Okay, then the next part, 2.2, they want the x-intercepts of f. F is the parabola, right? So f over here, this is the parabola. How do you know that? Well, you can see that over there. You can also see that the x is squared, so it is quadratic. It's your parabola. Okay, how are you going to find that? So we've already found this point over here, which was our 2, 0. Let's put it over there. That coordinate is 2, 0. Okay, so the straight line and the parabola, they share that x-intercept. Okay, so you've got one of your x-intercepts, you need the other one that's going to be on this side. Now what you know about your parabola is that it is symmetrical. What does the word symmetrical mean? It means the same on one side as it is on the other. So we've spoken about this axis of symmetry thing, right? And for our parabola that hasn't shifted left and right, our axis of symmetry is over there. So that means the same distance from year to year has to be from year to year. So we didn't do any math, just by understanding that this thing is symmetrical. If it's 2 units that side, it has to be 2 units this side. So this coordinate on this side will have to be -2 and 0. How did you figure that out? You know it's symmetrical. You didn't do any math. You didn't write anything down. You just know it is symmetrical. That's how you knew it was that point. Let's cut this video here. In the next video, we'll do the rest of the question.